of all, treated and untreated fibers are cut into 10 mm length. After that, made the fiber pad using fiber percentages. We use stainless steel mold for this work. Use two resins, polyester and epoxy. Then mold allowed to cool with curing time. After the curing process, test specimens were cut according to the ASTM standards: tensile strength, hardness, compressive strength, impact resistance, flexural strength, and moisture absorbency are the tested that we have done, or the tested had done according to the ASTM standards. Now let's look into the results and discussion of the fiber testing. The first test we have done is effective fiber length. The effective fiber length of Sansevieria salonica fiber is 30 centimeter, and it is measured according to the bundle. And the second test we have done for the fibers is tenacity. We have checked the treated and untreated salonica fibers tenacity from these. In this table you can see the treated and untreated fibers tenacity. According to the table, you can see the 28% higher tenacity in alkali treated Sansevieria salonica fiber, because the sodium hydroxide removes waxes, oil, hemicellulose, lignin and other impurities, so it leads to closer packed cellulose polymer chains. Due to the release of internal tension to increase the tenacity. In this slide, you can see the single fiber strength of treated and untreated Sansevieria salonica fibers. As per the table, you can see the breaking force increased by 9.12 and elongation reduced by 17.18 in the alkali treated fibers compared to the untreated fibers. Alkali treated Sansevieria fibers have closer packed cellulose polymer chains caused to increase breaking force and reduce the elongation. Higher fiber bundle strength and single fiber strength of alkali treated Sansevieria fiber and lower elongation percentage important for the good mechanical properties of composites. Let's move on to the next slide. In this slide, you can see the moisture absorbency of alkali treated and untreated Sansevieria fibers. Moisture absorption increased after alkali treatment and took comparatively high values. Alkali treatment changed the fiber structure during moisture absorption. Cellulose polymer chains in Sansevieria salonica fiber may be pushed apart by the absorbed water molecules, allowing more absorption. However, considering the mechanical and physical properties, we decided 5% alkali treated fibers for making composites. Let's move on. Now let's look into the physical and mechanical properties of Sansevieria salonica reinforced composites. Composites prepared with polyester and epoxy resins and separately use different fiber ratios: 20%, 30% and 40% and 50%. The first test we have done is tensile strength test. Tensile strength higher with epoxy resin based composite of all fiber ratios. You can see it in the given table. The reason is the epoxy polymer itself has higher tensile strength. The 40% fiber ratio shows higher tensile strength with both resin types due to better Sansevieria salonica fiber matrix interfacial bond. In this slide, you can see the hardness of Sansevieria salonica fiber reinforced composites and flexural strength of Sansevieria reinforced composites test results. In hardness test results, you can see the 40% fiber ratio has the highest hardness and the epoxy resin has the highest hardness level. The reason is epoxy polymer itself has higher modulus. The fiber ratio shows hardness due to the better distribution of fiber and matrix minimize the void and better Sansevieria selenica matrix interfacial bond. The 50% ratio, when it comes to the 50% ratio, no hardness shows due to not enough matrix in composites. So, the 40% is the best ratio for this test method. When it comes to the flexural strength of Sansevieria selenica reinforced composites, again the 40% ratio shows the highest flexural strength. And the epoxy resin 40% fiber ratio is the highest flexural strength. The reason is better interfractional bonding and avoiding the voids than the other fiber ratios with better fiber matrix distribution. Let's move on to the next slide. In this slide, you can see the impact resistance of Sansevieria selenica reinforced composite test results, and you can see the compressive strength of Sansevieria selenica reinforced composites. According to this, the 40% composite have better impact resistance compared to the other fiber ratios, and the epoxy has the highest compressive strength in 40%. This is happened because the greater absorption ability of energy to inhibit fracture development and good enough interfractional bonding of fibers and matrix. When it comes to the compressive strength, Sansevieria reinforced composite. During the test, the polyester and epoxy-based samples not cracked under the maximum load of 10 kN because it has good compressive strength and the composite has fibers layer. In this slide, you can see the moisture absorbency of Sansevieria reinforced composite and moisture regain. According to the moisture regain chart, you can see the 50% percentage shows a higher value than the 40%. Moisture regain of epoxy matrix is 30% and polyester is 0.4%. The conclusion of this project is shown in this slide. Alkali treated Sansevieria fiber composite, higher bundle strength and higher single fiber strength, lower break-in elongation and higher moisture absorbency. Let's move on to the next slide. Alkali treated Sansevieria selenica fiber-based composite have higher tensile strength, hardness, impact strength and flexural strength at the 40% fiber ratio than with the other ratios. Compressive strength, when it comes to the compressive strength, good with all composite types. Epoxy-based composite much better physical and mechanical properties than polyester-based composites, but moisture absorbency higher with epoxy-based composites. However, concluded that alkali treated 40% fiber ratio with epoxy matrix recommended for industrial applications such as cladding board, automobiles, aircraft, home appliances, and aeronautical applications. These are my references.
Okay, thank you very much for an interesting presentation. Can I request the audience to ask any questions you all have? Perhaps I can ask a question. Now, when you prepare the samples for testing, what were the dimensions of the sample that you have used?
Dimensions are 25 and 24, and height is 1.5 centimeter.
All in centimeters.
Yes.
So is it a uniaxial tension that you have applied, or is it a biaxial tension? Your fibers are in one particular direction, or are they in both directions?
Both directions.
Okay. But then you applied a uniaxial, you applied a stress or a strain in one particular direction. Am I right?
Yes.
The longitudinal direction?
Yes.
Okay. So, so your lateral fiber arrangements may not have some effect on your strength, but do you anticipate?
Fiber ratio affect on the
Yeah, Dr. Aptavira, that
Yes.
that we laid in this research project that the fibers have been laid in the multi-directional, really multi-directional. Okay. So
Okay.
this is the decision taken from the series of the literature survey the student has done, and
so
there are series
it is
of
at random directions, right?
Random directions. So then we did the composite the testings. There are six, I think 5 or 6 testings we have done. The tensile strength we can do only in the multi-direction. The forces are applied only in the lengthwise direction on the composite.
Direction.
So then, the lateral direction we measured the flexural, the 3-point bending equipment we use. Then the lateral effect is coming onto the composites. So then in addition to that, we did the impact strength, then hardness strength, and like that series of the mechanical tests.
Yeah, so what you're saying is depending on the application, you can decide on the fiber direction.
Yes, that fiber direction, multi-direction laying gets
certain applications
most good. And depend on particular direction. Only the force is applied in the lateral direction, then we have to lay in the lateral direction.
Okay, right.
It's a very general the testing. Yeah.
By the way, this hemp is hung, right, in Sinhala?
That is really we say the Sansevieria. So then in Sri Lanka name is I don't know, that Ceylon browsing hemp. Normally hemp I don't know the Sinhala name. So we can see that it's
hemp is like jute, or
jute is Sinhala we say that hana.
Yeah, not hana.
Not hana. Okay. No. So you can see that the ornamental this plant is we use as an ornamental plant in Sri Lankan homes.
Okay.
So yeah.
Right. So thank you very much, Dinusha, for your presentation. We'll move on to the next presentation. The next presentation is experimental investigation of modified cement mortar containing rice husk ash, and polymer adhesive. The authors are M. Chetamani, S.V. Velage, E.G.P. Veerasinghe, and I.S.K. Vijayawardena. Who will be presenting it?
Patung Vijayasinghe is a presenter.
Oh, okay, right. So you can go ahead, I believe.
Good morning,
Veerasinghe?
everyone.
Yeah. Go ahead.
I am Pathum Meerasinghe. Our project other members are SV Vyallage and C. Mahanan. Project supervised by Dr. ISK Vijayawardena. Our topic is experimental investigation of modified cement mortar containing rice husk ash and polymer adhesive. Overview. Introduction, study of polymer, study of RHA, methodology, mix design, resultant analysis, and conclusion. Introduction. Cement mortar is one of the vital material in the building construction industry. Cement mortar can be used mainly for blockwork and wall plastering. In most of the buildings, there are many defects due to the lack of bonding and low tensile strength of plaster, such as surface crack in plaster and deboning and flaking of plaster. Thermal expansion and drying shrinkage are the main cases for the above defects. Our research forecasts to improve cement mortar properties by using PVA and RHA to minimize above mentioned defects in cement mortar. Studying of polymer. In here decide to additionally apply polyvinyl acetate to generate extra bond between cement particle and fine aggregate. Structure of cement mortar had to positively change because of additionally polymer components. However, PVA hydrolysis when it react with chemically calcium hydroxide, which produces of Portland cement hydration. The following process is the crystallization of calcium acetate. Calcium acetate crystal dimension is extremely unstable because of its hygroscopic characteristic. Study of RHA. It is hoped that the use of RHA will reduce the amount of calcium acetate that is formed. The quantity of calcium hydroxide required to chemically react with PVA is decreased when amorphous silica in RHA combines with calcium hydroxide. This decreases the amount of calcium hydroxide required to generate calcium acetate, which lowers calcium acetate production. Methodology. Compressive and fractural strength tests were conducted according to the BSEN 1015-11. 7 mix designs were considered in this study, which were named as S1, S2, S3, S4, S5, S6 and S7. The detail of the test variable and mix proportion of the mix design are given this table. This figure shows the fractural strength test result. This specimen S3 indicates significantly high fractural strength compared to the control specimen. Furthermore, when the PVA content was increased up to 3% in specimen S4 and S7, the fractural strength both 14 and 28 days had noticeably reduced compared to that of specimen S3 and S6 respectively. This could be due to the covering up to the cement and RHA particles by the high PVA polymer content in specimen S4 and S7. Calcium silicate hydrate, primary gel and calcium hydroxide are formed when cement reacts with water. Moreover, the RHA produces the calcium silicate hydrate, secondary gel. When silica reacts with calcium hydroxide, the calcium silicate hydrate is the governing compound that contributes of the strength of cement mortar, whereas the compound calcium hydroxide had a negative impact of the cement mortar strength. When the PVA content was gradually increased up to 1%, look at the S3 and S6. The flexural strength of cement mortar had increased due to the binding effect of PVA. However, if the PVA content is further increased up to 3%, look at the specimen S4 and S7. It may act as the protective coating for cement and RHA particles and reduce the formation of calcium silicate hydrate, the hydration reaction. This figure shows the compressive strength test results compared to all the test specimens. Specimen S3 showed the highest compressive strength in the 28 days. The compressive strength of the cement mortar decreased when the RHA replacement was increased from 5% to 20%. Of the other hand, the compressive strength of 28 days was reduced in specimen S4 and S7 compared to the control specimen. Similar to flexural strength reduction is specimen S4 and S7, the compressive strength was also affected by the PVA coating formation around the cement and RHA particle, while it decreased the formation of calcium silicon hydrate gel during the hydration process. Conclusion: the 5% replacement of rice husk ash in the conventional cement mortar give the optimum flexural and compressive strength at 20% replacement of RHA. The characteristic compressive strength of the conventional cement mortar decreased by 24% or more. The mixed design of S3, 5% of RHA and 1% of PVA, gives the best mechanical properties in the cement mortar. Compressive strength 14.72 Newton per square millimeters and flexural strength 8.72 Newton per square millimeters. When the PVA content is increased beyond 1%, both the compressive and flexural strength of the cement mortar are significantly reduced. Thank you.
Okay, thank you very much for your presentation. Any questions from the audience? No questions. Okay, maybe I'll ask a question. Now, what is the application that you are looking at? Is it for plastering purposes or is it for any other application?
So mainly we focus to apply crack repair to the our material.
What do you mean?
Uh,
What is the specific application you are looking at?
so site levels, when we can apply at the like a conduit electrical path cover into the electrical path like that places.
It's the plaster that you are looking at, right?
Yes.
Cement mortar. Am I correct?
Yes,
Yes, sir. We are looking for the plastering repair.
Okay. So it will be open to the environment. Have you all looked at certain environmental issues that may arise? Now, as you said, the material can get, moisture can creep in. Have you studied any environment effects on, the application that you have highlighted? Anybody who want to answer? Maybe Dr. Vijayawardhan?
Hello. So,
Yeah.
yeah, we didn't consider the environmental aspects as this is an undergraduate project. So
Yeah,
we just want to, look into
Yeah.
the use of rice husk ash, which is a very commonly available material in Sri Lanka kind of countries. So the strength gain from the rice husk ash, and we can add some chemical, or which is a like a glue kind of thing, the acetate, PVA, and we can improve the further improve the flexural capacity of the and the tensile capacity, so that we were focused on that part.
Okay. So basically, the experimental setup you have used is for strength testing, right?
Strength testing to improve the crack resistance of the plaster.
Okay.
Yeah.
But then the dimensions of your specimens that you are used, it is just the cube strength and the flexural strength, right?
There's a specimen sizes. I think. Did you show
no
the experiment?
Only one slide which showed the.
Yeah, so they were according to
apparatus.
standards, British standard, and so not only cubes. We used some kind of cuboid, and we compressor and the flexural test were done in one test. You do the flexural test, then you cut some part of that specimen, and you do the compressive test. It's according to the standard.
Okay, ASTM, right?
No, British standard.
Okay, right. Then thank you very much for the presentation. We'll move on to the next one. Next presentation, just a minute. Next presentation is entitled A Harmful Websites Detection System Using Random Forest Machine Learning Algorithm. The researchers are HMGG Dhammika and DDM Ranasinghe. Dhammika, I believe you are presenting, right?
Yes, sir.
Go ahead. Yeah, please go ahead. We can't hear you. We can't hear you, Dhammika.
Oh, okay, sir. Can you hear?
Yeah, we can hear you now, but we don't see the slides.
Dr. Adnavira, they are playing the recorded version, isn't it?
Is that so?
The video was sent. So we
Who is
thought that
managing the
it's going to
system?
be.
Okay. Somebody is trying to play the video. Yeah. All right, you can play the video with the sound. No sound.
Sorry if I interrupt you, sir. How the previous presentations were done? Is it the automatically doing the
That's a
recording?
good question. That's a good question. I am also not very sure.
So I thought that when the recording was sent, they are going to automatically play the recording.
Yeah, but
Or else
unfortunately,
do we have to do the presentation just now? I think
since
she'll
you
be
don't
able
have
to
the
do
sound,
presentation.
yeah. Do you have the slides with you?
Yes, sir. I have.
Okay, so then can you share the slides and do the presentation? For some reason, the recording is not working. The sound is not working.
Okay, sir.
Ramika, can you do the presentation?
Okay, sir. Okay.
Okay, you can start.
Can you hear, sir? Hello?
Yes, we can hear you.
Go ahead.
Hello, everyone. Welcome to my presentation of research paper 166. The title of research paper is Harmful Website Detection System Using Random Forest Machine Learning Algorithm. The name of authors are HNGG Dhammika and DDM Ranasinghe, Department of Electrical and Computer Engineering. As mentioned in the table of content, the research information is mainly described under 5 headings. So I will explain the introduction of research. During this modern era, people around the world use internet extensively for work and other purpose. So the internet is most extensive network in world. This network also home to website that can expose people and computer system to harm. People and computer system can be attacked by malware, virus, and other harmful agents. Thus, identify dealing with infected website before normal user access them has become a top priority for the safety of user. Statement of problem is harmful website are engaged in illegal and non-ethical activities such as spam, financial scam, malware, agent, and they cause financial, personal, and many other serious losses globally. Aim of the research is to design and develop a harmful website detection system that can detect harmful website and its type of harmfulness based on machine learning technique and lexical feature of the addresses of the website. According to the literature survey, there are three many methods identification of harmful website. They are backlist approach, signature-based approach, and behavior-based approach. If I brief explain you about that method, backlist approach work based on compile list. Limitation of this are the data maintained is very difficult and newly generated harmful website cannot be detected. Behavior-based approach work based on the executable file behavior property. The signature-based approach work based on malware pattern extract from various malware. The limitation of this are high amount of manpower, time, money to extract unique signature. Proposed system has machine learning based training module based on lexical based characters of website address. So it has the capability to generalize a new website and not require high amount of manpower, time, money to extract the lexical based feature. Proposed system processing time and storage complexity is lower than other method. Considering system approach, when I was designing the system, I chose the technique that give the best performance after experimenting with different machine learning techniques for creating model 1. The software tool used to develop this system were Visual Studio Code and Django. The model design language was Python, while CSS and HTML were used to design the web application. During the first phase in the methodology, a data set was collected, the source indicated by appendix table, and 60,000 harmful web addresses and 60,000 benign web addresses were collected during the data pre-processing. In second phase, unnecessary column were taken out and necessary data bundles were merged to system. Because the web address have feature with string, they cannot be directly fed to the machine learning model. So the certain feature are taken from the web address, then they are fed to the machine learning model after pre-processing into a numerical format via EF-IDF vectorizer. Two data set were trained with random forest machine learning algorithm for model 1 and 2. In the third phase, user data training processing is created. System is developed to extract feature from the user input web address and classify whether the web address is harmful or not from model 1. In the case of harmfulness web address, system is developed to detect the type of harmfulness from model 2. The implementation chapter has been executed under two main sections. They are internal process creation and user GUI creation. Internal process have been created under 6 main subsections. They are based on steps described in the methodology section. User GUI have 3 web pages. They are home page, harmful status display page, and harmfulness type display page. While developing the first model, several different models were experimented with. However, the random forest machine model was chosen to develop to system because of its high level of performance. Image 5 show performance of the trained harmful status identification model. The total accuracy of this model is 0.998. Image 6 show performance of training harmfulness type identification model. The total accuracy of this model is 0.997. This research explored random forest machine learning techniques based on the lexical feature approach to identify whether a particular website is benign or harmful. If harmful, the type of harmfulness is also identified. The trained random forest classifier by the feature set give approximately 99.8 accuracy results. Users are able to interact with the system through the web interface where they can enter the specific web address to check website. The purpose of this system is safeguarding user by revealing the truth about harmful websites that victimize them. The reference data resources used in the research are shown in this slide. The data tables used in research are shown in this slide. That's the end of my presentation. Thank you for all listening.
May I invite for some questions from the audience? Any questions? Maybe I can ask a question, even though it's not my field of specialization. Now, how does it happen in real life? So when you go to a certain website, you activate your algorithm and then check that particular website. How do you know that this website is not a reliable source? Do you look at the operations that are going on in the background? Dhamika?
Yes, we will test many different malware website. And
yeah, I'm looking for the application part. How do you do the application?
I have application.
Dr. Menaka?
Yes, can I ask? I was waiting until she gives the answer because this is an undergraduate project which she completed for her undergraduate project. So actually what happens is, I mean, when you browse on the websites, when you Google, I mean, you can, before checking, so we don't know whether this is a harmful website or no. So what we can right click on and paste the website URL without onto this system, and then you can, then the system will tell you whether it is a malignant or a good one. I mean, you don't need to go into the website. So that is otherwise when we get to know that this is a bad website only after going there only, when the messages pop up. So this is before going, you can right click and get the URL and paste it over there. So that is how it's going to work.
Right. But then you can set up a machine to run, let's say 24 hours just to identify, such websites, because it is learning by itself, right?
Yes, I mean, at the moment we didn't go on to that extent due to the time constraints and all. What we said is that for an application where the individual persons can set up in their machines and do the checking.
But then it usually delays the browsing speed, right?
I don't think so.
Unless you automate it. Unless you automate it.
Yes.
That is when you click the website, it won't directly go there, but it will go to your machine.
Yes.
Check the website and then decide not to go, send a message to the website.
Yes, but we have not automated that part. We have not gone to that extent.
No, that's fine. I was just looking at the application side of it. Thank you very much.
Okay, welcome.
Yeah, we'll go to the next presentation if there aren't any questions. next presentation is IoT-based COVID-19 patient monitoring system. The authors are BGSP Sirivardhana, HMSM Herath, and DN Balasuriya. Who will be presenting it? You can switch on
Hello,
your.
welcome you all to our research presentation. Our research
Can you
is
identify?
IoT-based COVID-19 patient monitoring system, and authors are BGSP Sirivardhana, HMSM Herath, and DN Balasuriya. Introduction. COVID-19 has been a global pandemic that creates huge troubles for people's day-to-day lives from 2019. According to the WHO, over 6.5 million people have lost their lives during this global pandemic, and also more than 630 million cases have been reported. Vaccination has led to an increase in the immunity to the virus, but the risk had generated with new variants of the virus such as Delta and Omicron. Patients needed more attention from physicians because the new variants' death percentage were higher than previous versions. Treatment centers in some countries were fully occupied, so a large number of patients were treated under home quarantine. Even though they needed physician protection and instruction, that was not available most of the time because the capacity of physicians to reach patients physically was limited. To solve these practical issues, IoT-based COVID-19 patient monitoring system was suggested. The IoT is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. IoT and health technologies may revolutionize the healthcare industry over the next decade and thus significantly impact the healthcare systems. IoT is the most suitable method to use for these type of systems because it can avoid the spreading of the diseases from patient to physician. Aim and objectives. This research project aimed to implement a system for home quarantine COVID-19 patients to monitor their primary health parameters and keep their health good by recognizing critical moments remotely. And objectives are designing a wearable device to measure the body temperature, oxygen saturation level, and pulse rate of COVID-19 patients who are quarantined at home, designing a dashboard to monitor the COVID-19 patient remotely using IoT through the wearable device, and develop an Android application to change the SSID and password of the wearable device. Then related works. These are some of related works. We studied those for our research for get some ideas. Methodology. In this research, a wearable device has been designed that can measure the most important health parameters of the COVID-19 patient, which are pulse rate, oxygen saturation, and body temperature. Then the device sends the data to a PC terminal via a cloud server. The system has security protection, and if anybody wants to monitor a patient's stats, he or she should log into the system with a valid username and password. The system will show real-time data of patients who wear the device. This wearing device also has a display and it shows each measuring parameter. So the patient also can be aware of his biostats. Figure shows the general system architecture of the system. The sensor will measure the body temperature, pulse rate, and blood oxygen saturation of the wristbanded patient and update to the Google Firebase, and then the monitoring device retrieves data from the real-time database. The system will make emergency alerts when any patient is in a critical situation. According to the information that got from the physician of the teaching hospital Kuliyapitiya, critical situations of a patient can be determined as following. If body temperature value is greater than 37.5 Celsius, if pulse rate less than 60 BPM or pulse rate greater than 60 BPM, if oxygen saturation is less than 95%, he or she is a critical patient. This is the wearable device and which can measure pulse rate, oxygen saturation and body temperature. This is Max 30100 pulse oximeter sensor attached clip. This is the DS18B20 digital type temperature sensor attachment of the wearable device. Now you can see how wear the device on the arm. When finger clip is taken off, there is no any spike is generated by yellow line on the OLED display. But when finger clip is attached on the finger, spikes are generated by yellow line, which means the device sends pulse rate and oxygen saturation properly. Then measured pulse rate and oxygen saturation are shown on the OLED display. In every 30 seconds, measured body temperature is shown. While the measured data are shown on the display, the device sends all data to the online database. Now let's see how connect the device to the Wi-Fi connection according to the user preference by changing SSID and password using developed mobile app. After long pressing the push button of the device, you are shifted to Bluetooth mode. Then open the mobile app and select your device among paired Bluetooth list. I have named the wearable device as patient at this occasion. Now enter SSID and password of the Wi-Fi connection that you need to connect. After the enter button is pressed, device gets the data and connect to the new Wi-Fi connection. The dashboard is another main part of the design system. An HTML, CSS and JavaScript coded web application is used for this. A software was developed using the Python programming language to open the web-based application of the system. There are many web pages in this web application for particular tasks such as login, sign up, real-time monitoring, history checking, temperature versus time graph, and new patient registration. All pages are interconnected. Firstly, user should install and open the software. Then a graphical user interface is shown like this, and the user can open the login page by clicking the enter button. This is the login page. You can log into the system by entering a valid username and password. But if still you don't have an account, you can create an account by clicking create account button. This is the account create page. Authentication codes are issued by an authority who direct in the system. This is the real-time monitoring dashboard. This is the new patient registration page. This is patient history checking page. This page shows patient history up to last 7 days. This is a graph that generated by the system. By using this graph, the physician can easily analyze the patient's conditions. Next, conclusion part. This research designed a patient monitoring system for COVID-19 patients. While Sri Lanka and many other countries have been able to successfully control the spread of COVID-19 through vaccination, there are still patients that require close monitoring. The system user can monitor in real time and analyze the patient's past using the history grid and system generated graphs. This device can be used effectively for this purpose. In addition to COVID-19 monitoring, the system can also be used to monitor patients suffering from fever and other respiratory diseases. In addition to measuring the body temperature, pulse rate and oxygen saturation of a patient, the system can be modified to measure various health parameters. Then, the system can be applied to monitor all persons and babies' health parameters who live in the home when family members are busy. These are the references that we referred for our research. Let's wind up the presentation and thank you all.
Okay, thank you very much for an interesting presentation. Any questions from the audience? Maybe I can ask you a question. Dr. Menaka, I think you are muted. Dr. Menaka, do you have a question?
Yes, Dr. Ratnavira.
Yeah, go ahead. Go ahead, please.
I just wanted to know how they detect the patients.
Can the presenter answer that question, please?
Yes, sir. That's detects means then it's decided by the physician. No? That we only do is update the data of the patient.
Okay, so what you are saying is the instrument number can be transferred to the web portal website.
Sorry, sir.
Is that can you transfer the instrument
Yes,
information to the web portal?
Yes, each patient has a particular ID.
Yeah.
And then according to their ID number, real-time monitoring page shows the all data of the patient.
So do you input the ID to the device that you are using, or how does it go to the
Yes,
web page eventually?
When we register new patient, we have to input new patient ID to same time.
Right, but then it could detect the device, right, without any issue. When the data is being transferred, it could also let's say you are transferring data from several devices to the same portal.
Sir. Yes, sir.
Then it could identify the device as well.
Yes, sir. Yes. Database has particular nodes to each device.
Yeah.
Separately, then each device update their own nodes in the database, and database update the real-time page.
Yeah. Can I also ask now, from what you have done, I tend to come to the conclusion that it is mostly data acquisition. Where is the IoT part of it? What sort of IoT applications do you envisage?
Yeah, this remote monitoring. So IoT means this is the IoT monitoring part in this research.
Okay. So it's just transferring the data from the device to your web page, isn't it?
Yes, sir. So physician can remotely monitor the patient. That's the IoT part.
Yeah, but only the physician. Do you anticipate anything more to it? Because this will eventually end up as data, which can be made use of by authorities to make certain decisions, maybe at a country level or maybe a regional level, etc. Have you all looked into such applications? Probably not. Huh? Okay, so thank you very much for the presentation. We will move on to the next presentation. Next presentation is development of a low-cost sealing board produced from a composite of cement, sawdust, rice husk, ASH, rice husk, ASH, and that is ash and waste polyester yarn. The authors are A. Ushantini, V. Kuvirajan, M. Sri Piranava Ruban, and LSS Vijayavardhana. Yeah, you can make presentation.
Good morning, everybody. Thank you for giving this opportunity to present our research. My name is A. Ushantini. My group member M. Sri Pranavaruban V. Puvirajan. Our supervisor, Engineer LSS Vijayavardhana sir. Our topic, development of low-cost sealing board produced from a composite of cement, sawdust, rice husk ash and waste polyester yarn. Introduction. Sealing board is the panel sheet covering the upper layer of an internal section of a building, which improves its aesthetic and reduces heat and sound transmission in the building. It should not affect human health. Some typical sealing boards are gypsum, asbestos, gypsum fiber, and timber sealing board. Problem identification. Asbestos used in most residential buildings is associated with lung cancer and therefore is prohibited in many countries. Second one, agro waste disposal method. Common disposal method is incineration or burning. It leads to increased level of carbon dioxide in the atmosphere, which increase global warming. Uncontrolled disposal causes pollution in the canal, riverbank, and village road. To tackle the above problem, 3 such problematic waste material, rice husk, sawdust, and polyester yarn, together with ordinary Portland cement as the binder, were used to make an asbestos-free composite sealing board in this research study. Aim, investigate a mix of cement, rice husk ash, sawdust and waste polyester yarn to produce low-cost and environmentally friendly sealing board. Objective, investigate a mixing proportion of the above raw material, testing the specimen to evaluate the strength. From that, find out the optimum mixing proportion to produce low-cost and environmentally friendly sealing board economically. Methodology. Literature review from the past research paper, journals and technical reports. Pre-testing. Collect the raw materials and get it to record stage. Especially, rice husk convert to ground rice husk ash foam because of its cementitious properties to reduce the amount of cement which is only costly material of this constituent. Then select the best percentage of polyester yarn as 0.8% and ratio of sawdust and rice husk ash as 50% of remaining content from the previous research conducted on the selected material to produce similar products. Testing, pre-sampling and select the best range of cement content, cast cubes with various percentage of cement content, analyze the compressive strength of specimen after 7 and 28 days. After selecting the preferred range of cement content from the above test, cast 5 different samples varying the cement content in 5% interval within the selected range. Conduct the record test. Then result analysis. Compare the result with standard and other types of boards. Find the best proportion to produce low cost and environmental friendly sealing board. Suggest the optimum mix. This table shows the mix proportion which were tested in this study. The cement content varying from 60 to 40% and ground rice husk ash and sawdust have equal percentage of remaining content. The polyester yarn percentage was constant at 0.8% in all 5 mix. This picture shows the raw material of the research. This table and graphs show the compressive strength result, which varies between 539.4 and 4673.3 kilopascal, as well as which increases with increasing cement content. According to the ASTM standard compression strength requirement for sealing board, 448 to 868 kilopascal. Hence, all the tested samples satisfy with ASTM standard. These favorable results are due to the adequate compaction and finer property of sawdust, rice husk, and cement content. Flexural strength. This graph and table show the flexural strength result, which is varies between 1.72 to 2.87 megapascal, and sample M1 shows highest value and M5 has least. According to the ASTM standard, flexural strength range is 0.03 to 0.07 megapascal. Hence, all the samples have good resistance to flexural failure. This favorable result might be the polystyrene content. Split tensile test result varies between 468.5 and 1149.8 kilopascal, and M1 sample shows highest value and M5 sample has the least. Density of composite board varies from 1077.8 to 1332.4 kg per meter cube, and ASTM standard for ceiling board between 350 to 400 kg per meter cube. Hence, all the samples have much higher densities than standard. Water absorption values varies 9.7% to 19.39%, and M5 sample shows the highest value and M3 has the least. Summary. This table shows the comparison of physical and mechanical properties of CCB with other types of ceiling board and ASTM standard. Density of CCB highly satisfied with standard and other types of ceiling board, and water absorption values lie with the range of fiber cement flat board, trellis board, masonite AC flat board, but outside the range specified in the ASTM standard. Further, flexural strength value highly satisfied with ASTM and asbestos ceiling board, but outside the range of the other type of ceiling board, as well as compressive strength value highly satisfied with ASTM standard. Cost analysis. This graph represents how cost of the production of CCB compare with standard type of ceiling board in 1200 into 1200 millimeter in size that are currently available in the market. It shows that CCB is the cheapest with wide margin when compared with other widely used ceiling board. In that respect, Mascon asbestos ceiling board, EL Toro non-asbestos ceiling board, PVC ceiling board are respectively 269%, 193% and 341% more expensive compared to the cost of CCB. The main reason for this is that other than cement, all other constituent material used in making CCB, rice husk, sawdust, polystyrene are waste material. Conclusion and recommendation. The strength of all the samples met the ASTM standard for ceiling board. Water absorption property is satisfying with fiber cement flatboard, trellis board, masonite AC flatboard. Moreover, it is economical and environmental friendly material. Hence, it is highly recommended that the composite of rice husk, sawdust and polystyrene with cement is suitable for producing ceiling board that could be useful for indoor and outdoor purposes. And it's more efficient when coated by any waterproofing agent such as paint, varnish or sealer, etc. Further study is necessary to tackle the water absorption property by reducing the polystyrene content and continuing with fire resistance, durability, thermal conductivity and modulus of elasticity test. Problem faced. Sample with cement content of 40% and 45% with the water cement ratio 0.5 to 0.7 failed while mixing and demolding the sample. Therefore, the water cement ratio of 1.0 was used in this study. Also, after final setting, the specimen has less rigidity as shown in this figure. This figure shows sample with cement content of 40% and 45% with the water cement ratio 0.5 to 0.7. Thank you. Any questions?
Yes, any questions from the audience? Maybe I can ask a question from you. When you prepare the samples, there seems to be some compaction issue, right? Why don't you get a smooth surface when you prepare the cubes? Any response from you? Is the author here? Mr. Saman Vijayawardhan is here. Maybe he could answer. Ushantini is here. Ushantini?
Let Ushantini answer, Dr.
Yeah,
Ratni.
yeah, no problem. Yeah. Problem is she has a connection issue. Okay. Ushantini, can you respond to that question, please? We can't hear you. Okay, please speak up. Okay, I'm not getting an answer. So what shall we do?
Probably she did not hear the question, Dr. Ratni.
Sorry?
Probably she did not hear the question. Can you repeat?
Okay, right. Let me repeat the question. When you all prepared the cube samples, it didn't yield a proper smooth surface. Is there any reason for that? When you demolded, you got a rough surface. Any reason for that? She's no longer here. She's here. We can't hear you, Ushantini. Your mic is not working. Yeah, you are talking, but we can't hear you. Can others hear Ushantini? Someone, your mic is switched off. Yeah.
Yeah, Ushantini, can you hear the question, Ushantini?
Sir, can you hear you now?
Yeah, we can hear you now. Go
Okay,
ahead,
sir.
please.
Sir, I connect from another device, sir.
No,
Sorry
we
for
can
the
hear
interruption.
you.
Okay, sir.
Go ahead.
Sir, can you repeat the question?
Yeah, now when you prepared the cube samples and
Yes.
when you demolded, it didn't yield very smooth side surfaces. Any reason for that?
Yeah, sir. Because of the low content of water, sir. That means the water. That's why we are using the water cement ratio as 1.0. When we use the water cement as a ratio in 0.6 to 0.7, that is the reason for that picture shown in the. Okay.
So then if you have too much water, then the cementation will be affected, isn't it?
But when we test the compression and flexural and strength, we got the value which is more than the ASTM standard value, sir.
Okay, so which means your other materials are absorbing the water that you put in.
Maybe, sir. Yes, sir.
Later it evaporates, maybe.
Maybe the polyester yarn is the reason for absorbing more water.
Okay. So, did you come across any literature on these test procedures
Yes, sir. We
using
got
similar
from,
material?
yes, sir. In from the previous literature view, they do same composite, but not the same. They used binder material as industrial starch or urea formaldehyde, like that. Not use cement.
Okay. Okay. Right. All right. Thank you very much.
And okay, sir. Thank you, sir.
Yeah. Is there any other clarification you would like to make? Please go ahead.
No, sir.
Okay. All right. Since we don't have any other questions, let me thank all of you for joining this session. The session has come to an end. We don't have the required number of papers there. Technically, we could accommodate another 2 more papers, but this is what we have. Before I wind up, I would like to thank everyone for joining this session. Okay, I'll be leaving.